Assalamu alaikum everyone. Today's video is on similar shapes. Similar shapes are shapes that are enlargements of each other. Normally we have a scale factor which basically tells us by what amount each shape has been enlarged. Okay, a few pointers about similar shapes. So the scale factor would be the same across all the sides in similar shapes. So if the scale factor was 2, all of the sides from one shape would be 2 times larger the other shape, but the angles would remain the same. We've got a couple of examples here. So we've got two triangles, a blue one and a red one, and we're going to check if these two shapes are similar. So in order for that to happen, first we got to see which sides correspond to which one. So this one, I'm going to label it number 1 here. This side in blue triangle corresponds to this side in the red triangle. This side in the blue triangle, number 2, corresponds to this side in the red triangle, and this side, number 3, in the blue triangle corresponds to this side in the red triangle. So in order to check if these two triangles are similar, I'm going to find the scale factor for each one of the sides in both the triangles, and the way I do that is I just divide the larger one by the smaller one. So 10 divided by 5, and that's my scale factor 2. The scale factor number 2, that's this 10 divided by 5 again, that's also 2. And scale factor 3 is going to be 12 divided by 6, that's going to be 2. Since all three scale factors are 2, I can say that the two triangles are similar. Okay, also what I need to just explain quickly is this angle here is the same as this angle over here. This angle here will be the same as this angle here, and this angle here will be the same as this angle here. When we're dealing with triangles, it is enough to say that if angle 1 is the same in one triangle is equal to angle 1 in the second triangle, angle 2 in the first is the same as angle 2 in the second, and angle 3 will obviously be the same. So if all three angles in one triangle are equal to all three angles in the second triangle, then those two triangles are similar. So that's an advantage we have with dealing with triangles. But when it comes to rectangles, for example, all rectangles have angles of 90 degrees, right? Just like squares as well, right? But rectangles is a bit of a tricky shape when it comes to similar shapes. So all rectangles have 90-degree angles. All 4 angles are 90 degrees. So in order to check if two rectangles are similar, we have to look at their scale factors just like we did for the triangles. So first we're going to find out what sides correspond to which one in the two rectangles we have. So that one corresponds to that one, and that one corresponds to that one. So I'm going to find the two scale factors. Scale factor 1 is going to be again the larger one divided by smaller. So 10 divided by 8, that's 1.25. And then scale factor 2 is going to be 8 divided by 6, that's 1.3 recurring. So I can see that the two scale factors are not the same, So this means that the shapes are not similar. Okay, and the reason they're not similar is because the two scale factors are not the same. So the enlargement, well, we can't call it an enlargement because it wouldn't have been in the same proportion. It's an enlargement only if the scale factors are the same. Alright, so what we're going to do in this video is we're going to look at another example where we have two similar triangles and we have to find some missing lengths, and after that you guys are going to have a go at two questions, and after that you can have a look at the answer for that. So let's look at our example. So in this example we have two triangles where we have a big triangle, triangle ABC, and a smaller triangle, triangle ADE. The two triangles share the same angle A, which is the white one over there. You see these two green lines, these two green arrows tell me that these two sides are parallel. So the red angle on the left, angle ADE, is the same as angle ABC because they are corresponding angles, and similarly angle AED is equal to angle ACB, and the reason for that is they are also corresponding angles. So this means that all three angles in triangle ADE are equal to all three angles in triangle ABC. That is enough to say that the two triangles are similar. Right, what I'm going to do now, remember that is something we do specifically for triangles. I'm going to draw the two triangles individually because this diagram can look quite confusing. So I'm going to draw two triangles individually, split them up, and I shall then be able to answer the question better, I believe. Okay, that's just a quick tip for you guys as well. Now I'm going to label the smaller one ADE so you can visualize things a little bit better. AD is X, AE is Y, and DE is 3 centimeters, and then triangle ABC, AB is 12, AC is Y plus 4, and BC is 9 centimeters. Okay, so the next thing I need to do is just quickly jot down which side corresponds to which. So those two correspond, these two correspond, and these two correspond. So to find the scale factor, I'm going to start off by finding the scale factor. Scale factor is going to be 9 divided by 3. I have the two lengths of those two sides, so that's going to be my scale factor is 3. Okay, so I know now I'm going to find out the length of AD, and AD is length in the smaller triangle, so I'm going to divide the length of AB, which is a length in the larger triangle, by 3. So I'm going from larger to smaller, so I'm going to divide which is 4 centimeters. So I'm talking about this one here, that's 4. And now I need to find y and y plus 4. They're both unknown, so I know that AC is the larger one, so it's 3 times the smaller one because the scale factor is 3 times AE. So AC is y plus 4, and that's equal to 3 times AE is y. So I can rewrite that as y plus 4 is equal to 3y. Now whenever I'm dealing with equations where the unknown is on both sides. I look at the one with the smaller coefficient and get rid of it. So I'm going to subtract y both sides. I'm going to carry on the side here. So I'm left with 4 equals 2y. And now I can divide both sides by 2. So y equals 2. That means this is 2 centimeters. And y plus 4, or should be 6, which is 6. And just to check it, we'll also find 3y. It's 3 times 2, which is also 6. So that means this answer is 6 centimeters, and that's the correct answer. So that's how I find the missing lengths using similar shapes. Have a look at these two questions. So question 1, you have triangle ABC, which is similar to triangle CED, and you're supposed to find the missing lengths A and B. And in question 2, you have triangle PQR, which is similar to triangle MQN, and you are supposed to find the missing lengths X and Y. Okay, pause the video, have a go, and when you're ready, when you've got your answer, play it and see what you get. Okay, I'm gonna go over the answers for this. So question number 1, let's start off. Right, what I've done is I've marked, I need to first find out which angle, why these two triangles are similar. Sorry. So you can see these two white lines here, white arrows. They're telling me AB is parallel to DE. So angle BAC and angle CED are alternate angles. They make like a Z shape, and alternate angles are equal. So these two angles are equal. Similarly, these two angles are also equal. Angle ABC makes a Z shape with angle CDE. They're also alternate angles, and they're equal. And angle ACB is equal to angle DCE, and the reason for that is they are vertically opposite angles, and vertically opposite angles are equal. So that would mean that the 3 angles in the smaller triangle are equal to the 3 angles in the larger triangle. So they are similar. So what I need to do now is try and find out which side corresponds to which, and that can be tricky in this kind of diagram. So I'm going to use the angles to help me out. So AC over here, I'm going to number it number 1 here. And if I look at the ends of AC, I've got the red angle and the blue angle. So the side that will correspond to AC will be the one which has the red angle and the blue angle, which is CE. Right. And similar, BC has yellow and the blue. So I'm going to number that too. That would correspond with CD because it has the yellow and the blue. And AB quite clearly corresponds to DE. Okay, so I need to first find the scale factor. So I need 2 corresponding sides and their lengths. So I can do 6 divided by 3. My scale factor is going to be 2. Okay, so the next thing I'm going to do is find out CE. To find out CE, I would double AC because I'm finding the larger length this time. So the smaller length times 2 because our scale factor is 2. So 2 times 4 is 8. So this is 8 centimeters. And then if I look carefully at this triangle, this side and this side are equal. That means they are isosceles. So that would mean this side is 4 centimeters. And similarly in this triangle, these two sides are equal because they are isosceles and it's marked. So if this side is 8 centimeters, this side will also be 8 centimeters. So let me just write down CD is the same as CE, and that is 8 centimeters. Okay, now we'll come to question 2. I shall do it in a different color. Let me do it in white. Okay, so here's a question which is a bit trickier than the previous one. In this kind of question, I would redraw the diagrams so as 2 different triangles. Let me redraw that line 1 second. So I'm going to draw the smaller one first, MQN, and then the larger one. So got more space here. Okay, so I'm going to write down, label this diagram MQN. MQ is 6 centimeters, QN is Y, and MN is 10 centimeters. And then I'll write down P, Q, R. PR is 15 centimeters. PQ is X plus 6. And QR is Y plus 4. So I need to find those 2 missing lengths also. Okay, so the first thing I need to do is find out which sides correspond. So that one, MN, corresponds to PR, then PQ corresponds to MQ, and QR corresponds to QN. Again, the way I know that is by looking at the diagram. I know from the 2 white arrows that these 2 sides are parallel. These 2 white arrows, so the 2 red angles are corresponding angles, and so are the 2 blue angles. They're corresponding angles, and corresponding angles are equal, and the yellow angle is shared by both of them. Both of them have the letter Q, so that's how I found which side corresponds to which. The next step is I need to find my scale factor. I'm going to change the color for this question number 2 here. So scale factor, I need the lengths of 2 corresponding sides. So 15 divided by 10, I always do the larger one divided by the smaller one. So that gives me 1.5. That's my scale factor. So I know the next thing I want to do is find the length PQ, which is over here. So PQ is 1.5 times larger than MQ. PQ is X plus 6. That's 1.5 times 6, which is 9. So to find X, I just subtract 6 both sides. So X is 3, which would then lead me on to find PQ. So PQ would be, oh, I've run out of space, have I? No, I can write something below. So PQ would be 3 plus 6, which is 9 centimeters. Let me see if I can just shift while working out. Be nice if I could have just moved it. Anyway, I now focus on the next part. I'm going to write it in yellow because I really have very limited space, and this is the trickiest part of the question. So now I'm going to use Qn and Qr. I know Qr is the larger side, so Qr is 1.5 times Qn. Qr is y plus 4 is equal to 1.5 times y. So I'm gonna get rid of the smaller coefficient. Oh, should be alright for this space, I believe. Smaller coefficient is y, that's 1y, so subtract y both sides. That gives me 4 equals 0.5y. So I divide both sides by 0.5. Just gonna move here. So y is equal to 8. So y is 8 centimeters. So QR is y plus 4. So y plus 4 is 8 plus 4 is 12 centimeters. So Qn will be 8 centimeters and Q will be 12 centimeters. Okay, so that's gonna be it for this particular video, which was on finding missing lengths using similar shapes. I'll probably try and do another video on finding missing areas and volumes, but that's for 2D and 3D similar shapes. Thank you for watching this video. Hopefully it helped.